In today's video, we're going to take a look at how particles can bond together through ionic bonds. And to explain this, we'll take a look at some dot and cross diagrams. First though, I just want to recap what ions are. We said in a previous video that ions are formed when atoms lose or gain electrons. And we can show this happening with equations. For example, a sodium atom will go to form a sodium 1 plus ion plus 1 electron. We know this because if we look at a diagram of a sodium atom, it has 1 electron in its outermost shell that it needs to lose in order to become stable. Because remember, stability is all about having a full outer shell. Meanwhile, for chlorine, we'd write that chlorine plus an electron, which we can see it needs to complete its outer shell, goes to form a 1 minus chloride ion. Now, this is all well and good in theory, but in real life, these reactions don't happen in isolation. Instead, we normally talk about a transfer of electrons, from an atom that has too many, like sodium, to an atom that doesn't have enough, like chlorine. Once this electron has been transferred, both atoms become ions, with full outer shells of electrons. So we put big square brackets around them, and their charge in the top right corner. The important bit here is that the two ions have opposite charges, so they'll be attracted to each other by electrostatic forces to form an ionic compound. We call this force an ionic bond, and it's really strong, similar in strength to covalent bonds, which we cover in another video. The way that we've drawn our compound here is known as a dot and cross diagram, and you'll often be asked to draw things this way in your exam. To do it properly, there are a couple of features to notice though. One is that we've drawn the electrons of one atom as dots, and the other as crosses. This is so that we can tell which electrons belong to which atom. And you should show the movement of any electrons with an arrow. Notice that in this dot and cross diagram, we've shown every electron shell of the atoms. Sometimes though, you'll be told you only have to draw the outermost shell, which is a bit quicker to draw. And for our example, it would look like this. Let's consider a harder example. Draw the dot and cross diagram for the formation of magnesium chloride, MgCl2. Only draw the outermost shells. Now this time, we can see that we have 3 atoms in the compound, rather than 2. To start, let's draw out our reactants. We have magnesium, which has 2 electrons in its outer shell that it wants to get rid of, and we have 2 chlorines, both of which have 7 outer electrons, so we need 1 more each. The next step is to think about where the electrons could move to make all the electrons happy with a full outer shell. And as a general rule, electrons will move from the metal to the non-metal. So in this case, magnesium can give 1 electron to each of the 2 chlorines. As a result, we'll end up with a magnesium 2 plus ion and 2 chloride 1 minus ions. This is now pretty much done. However, in dot and cross diagrams involving more than 2 ions, we generally arrange the ions like they would be arranged in a real compound. So because the chlorides would both be attracted to the positive magnesium, we place them on either side of it. And that's